All right, we're looking at number 9B here. Construct and interpret a 90% confidence interval for the difference between the true proportion of adult internet users in these age groups who use Twitter. So you can pause the video and read the context if you'd like. But essentially, we've got two age groups, and we're trying to look for a difference in the proportion that use Twitter. See if the older group, or actually the younger group, uses it more than the older group or not, is basically what's going on. So 90% confidence interval. We gotta go through our process here. So state is we will construct a 90% confidence interval. So you're literally just repeating this. All this stuff, good stuff, good fun. The only other thing under state that I would do is define your parameters like I have up here. So p hat A is a proportion of adults 18 to 29 that use Twitter, and p hat B um, is a proportion of adults 30 to 49 that use Twitter. So just make a note of that. We're going to make that statement. We'll construct a 90% confidence interval, and we're also going to define our variables or our statistics, our p hat A and p hat B. All right, next step, plan. So we want to check the conditions here. So the conditions are my samples A randomly selected. So we've got a random sample of 316 and a random sample, separate random sample. So um, big thing here is we got to make sure that both of them are randomly selected. Okay, number two, we're going to make sure that both samples are less than 10%. So 316 adults from 18 to 29 is certainly less than 10% of that population, and 500, what was it, 532 adults, 30 to 49 is less than 10% of that population. So we're good there. We're less than 10%. Our samples are not too big, and now we need to make sure that our samples are big enough. So we got 316 adult internet users, and we're gonna go with n of the first one times p of the first one, or p hat of the first one. So we need to expect greater than or equal to 10 here. 0.26 times 316 is certainly greater than 10 here, and we also need to expect 10 failures or more. So we need, I'm going to call this Q hat. Hopefully we all know what I'm talking about there. But Q hat, n times Q hat for that sample has got to be greater than or equal to 10. And again, 316 times 0.74 is certainly greater than or equal to 10. So we got to do this for both samples. You don't have to go through this whole process of defining your stuff, but make sure that we check this and record this for both samples. So 532 is our sample size for the second one, times 0.14 is definitely greater than 0.10, and also 532 times 0.86 is going to be greater than or equal to 10. So that condition, all three conditions, check out. Under do, we're going to state the test. So these conditions, checking out, enables us to do a confidence interval for the difference in two proportions. So this is a 2 prop z interval. And again, it's a z interval because we know that this is normal, as this condition tells us here. And because it's normal, we can use that z distribution, or a standardized distribution. So it's a 2 prop z interval. We got to make sure that we don't just spit that out and then run the use our calculator to run this. We got to make sure that we give them the important stuff. So first and foremost, the important stuff, we're going to look at the differences between our two proportions. So the first proportion is p hat A minus the second proportion is p hat B. in this particular case. And you can use different things other than A and B, but the difference in our sample proportions is going to be equal to, in this particular case, 0.26, or the proportion of 18 to 29, minus 0.14, or the proportion of 30 to 49, which equals 0.12. The reason we do this is basically the center of our interval. So we want to tell them where our interval is going to be centered. We also want to tell them our Z star, which for a 90% confidence interval is 1.65. And we also need to report our standard error in this case of p hat a, or the differences of proportions. This we can get from our calculator once we run our calculator, or you can calculate it by hand. I'm assuming you don't want to do that. So let's go to the calculator stuff. So we want to press menu, go to statistics. This is in the Inspire. And we're running a confidence, or we're finding a confidence interval right now. So the confidence interval that we're finding is a 2 proportion Z interval. And once I click on that, it tells me the information that I need to plug in. So I need the number of successes, which is, if I go back here, over here, I've calculated on a separate sheet or separate tab here. The number of successes for the first one is 82.16. And the number of successes for the second one is 74.48. So we go back to our calculator here, find our confidence interval, 2 prop Z interval, and 82 was the first one. We went around down, so we enter 82, and that's out of 316 samples, or a sample of 316. The next one was 74.48, so we would enter 74, again round down, and that's out of 532. And our confidence level, we want a 0.9 confidence level. All right, run that, and it spits out all this stuff. So what we're interested in here is, here's our lower for our interval, here's our upper for our interval. Our margin of error, if we need it, is in here. We don't necessarily need that because we're just interested in the interval. And what else do we need here? So we got this interval here. That's the interval we're going to report. So the lower is about 0.073. The upper is about 0.168. So 7.3% to 16.8%. So let's go back and finish this up. So we're going to conclude that we are 90% confident that the true difference in proportion of 18 to 29 and 30 to 49-year-olds is between, and what were those things again? They were 7.3 and 16.8%.